one naming instead of X. And be sure to change that here as well. Now, when I run this code, we're completing, let's see, 27 iterations. To exit this for loop, we need to count the numbers 1 through 9. Once we do so, that is one iteration like prints. With print that structure that we will enter columns. For the second bit, we will print tuples. Buddy, today I will be explaining a few different types of collections in Python. There's 4 general purpose collections. 3 of them are lists, sets, and tuples. There are also dictionaries, but I'll save that for the next topic because they can be kind of tricky. A collection, I would think of them as a single variable, and I'm saying that within quotes, that is used to store multiple values. That's how I would explain a collection to a beginner. For example, let's say we have a variable. Variable fruit. Fruit equals some value, like apple. And then I can print this fruit, which is apple. I could turn this variable into a collection by surrounding my values with either a set of square brackets for a list, curly braces for a set, or parentheses for a tuple. Let's begin with the list. If I would like to store more than one value in this variable, I will surround my values with a set of square brackets. This variable is now a list. I can store multiple values separated with a comma. Not only do we have an apple in this variable, but we have an orange, a banana, and coconut. One naming convention that I like to use, if I declare a collection, such as a list, set, or tuple, I like to take the variable name and make it plural, just so that it's more obvious that this is a collection of values. Technically, in the English language, fruit would still be plural. English is a weird language. We now have a list of fruit named fruits. If I were to print my list, this is the result. We have all of our values enclosed with a set of square brackets. To access one of these elements found within your list, you can use the index operator, much like what we can do with strings. The first element would have an index of 0. That would print my value apple. Index of 1 would be my orange. 2 is banana. 3, coconut. What about 4? We don't have a value there. List index out of range. Each value in a collection is also known as an element. If we attempt to access an element that's not found within our collection, you'll run into an index error. With the index operator, you could set a beginning index, an ending index, and a step. I would like the first 3 elements. You could say 0, 3. That would give me apple, orange, banana. Technically, you don't even need the 0. You'd need that colon, though. We can even use a step. I would like every second element. Apple, banana. It's every second element beginning from index 0. Maybe I would like my fruit backwards. I'll set the step to be -1. Coconut, banana, orange, apple. You can use the index operator with collections, much like you can use with strings. Another cool thing you can do too with collections is that you can iterate over them with the for loop. For x in my collection, fruits. What would we like to do? I will print whatever x is. So we have iterated over our list. Apple, orange, banana, coconut. Now x isn't really too descriptive. What you'll see some people do is that with their collection name, it's plural. Their counter will be the singular version of that word. If our collection name is fruits, let's rename x as fruit, singular. It's not mandatory, but that's a common convention. It's more readable that way. For every fruit in fruits. If this were cars, you could say for car in cars. Our counter is storing whatever value is within our collection. So what are all the different methods that we can use with collections? To list the different methods that are available to a collection, you can use the dir function, Within this function, add your collection, fruits. But we would need to print this. Let's surround this function with a print statement. These are all in alphabetical order. We have attributes, which I have not explained yet, but I will in a future topic. But if we scroll to the end, we have a bunch of different methods that this list can perform. Append, clear, copy, count, extend, index, insert, pop, remove, reverse, and sort. If you would like a description of each of these methods, there is a help function. Help, add your collection to the parentheses, then we would need to print this. Here's a description of all the methods and attributes. For example, we have our sort method, and here's a description. Sort the list in ascending order and return none, and then a bunch of other stuff. If you ever forget what you're capable of with a list or other collection, you can always use the help function to print a description of the attributes and methods available. If you need the length of how many elements are within a collection, there is the length function. Return the length of my list fruits, then let's print it. There's 4 elements within my list. The length function returns 4. If I were to add an extra element, like a pineapple, then that number would be 5. Let's remove that. Using the in operator, we can find if a value is within a collection. Is our value apple in fruits? But then we would need to print this. This operator will return a Boolean, so let's print whatever that is. Is apple in fruits? That is true. But is pineapple? Pineapple is not. It's false. You can use the in operator to find if a value is within a list, and that applies for your other collections too. With lists, they're ordered and changeable. Duplicates are okay. We can change one of these values after we create our list. Let's take fruits at index of 0. I will set this equal to be a pineapple. Then let's iterate over our fruit using a for loop. Okay, the first element is no longer an apple, it's a pineapple, then orange, banana, coconut. Using an index, you can reassign one of the values. If I were to change 0 to 1, well, now we have an apple, pineapple, banana, coconut. Let's cover some of the methods that are found within a list. We can append an element. Type the name of the list, dot, append. What would we like to append to the end of this list? Let's append a pineapple. I'm going to get rid of this for loop. I'm just going to display my list. There, we have an apple, an orange, banana, coconut, pineapple. To add an element to the end of a list, use the append method. To remove an element, you can use the remove method. Fruits.remove. Let's remove our apple. Our apple is no longer there. We have an orange, banana, coconut. Using the insert method, we can insert a value at a given index. Fruits.insert. List an index. 0 would be the beginning, then a value. Pineapple. Now we have a pineapple, apple, orange, banana, coconut. The sort method will sort a list. Fruits.sort. These are all in alphabetical order now. Apple, banana, coconut, orange. To reverse a list, you would use the reverse method. Fruits.reverse. Coconut, banana, orange, apple. However, these are not in reverse alphabetical order. These elements are reversed based on the order in which we place them. If you would like reverse alphabetical order, you can first sort and then reverse. Now we have orange, coconut, banana, apple. To clear a list, use the clear method. Fruits.clear. All of the elements are gone. We can return the index of a value. Let's return the index of apple. Fruits.index, list an element. Then we will need to print this. Let's print the index that is returned. The index of apple is 0. Coconut, that would be 3. What if we don't find a value, like a pineapple? Well, we have an error. Pineapple is not in list. You could count the amount of times that a value is found within a list, because duplicates are okay. Fruits.count. Let's count how many bananas are in this list. Banana. Then print it. 1 banana is found within this list. How about pineapples? There are 0. Now, those are lists. Surround your values with a set of square brackets. These values are ordered and changeable. Duplicates are okay. Now let's talk about the next collection, which is a set. To create a set, surround your values instead with a set of curly braces. 1 banana is... How many bananas are in this list? Banana. Then print it. 1 banana is found within this list. How about pineapples? There are 0. Now those are lists. Surround your values with a set of square brackets. These values are ordered and changeable. Duplicates are okay. Now let's talk about the next collection, which is a set. To create a set, surround your values instead with a set of curly braces. Our collection of fruits is now a set. A set has different benefits. The values are unordered and immutable, meaning we can't alter these values. However, we can add and remove elements. A set does not include any duplicates. I'm going to delete these methods, then print fruits. We have all of the same values, but they're not in the same order as they were originally. A set is unordered. If I were to run this again, they will likely be in a different order. See, now we have a banana, apple, coconut, orange. To display all of the different attributes and methods of a set, you can use the dir function. And here's all of them. Some of these methods are a little more advanced, but there's a few we might recognize, like add, clear, copy. For an in-depth description of these methods, you can use the help function. Much like what we did before. To find the length of our set, we can use the length function, which is 4. We can use the in operator to find if a value is found within the set. Unfortunately, pineapples are not within our set. Now, if I was to use the index operator of my set, this is what would happen. We have an error. Set object is not subscriptable. We're not able to use indexing on a set because they're unordered. Object set value is found within the set. Unfortunately, pineapples are not within our set. Now, if I was to use the index operator of my set, this is what would happen. We have an error. Set object is not subscriptable. We're not able to use indexing on a set because they're unordered, much like what we can do with a list or a string. We can't change the values of a set, but we could add or remove elements. Let's use the add method to add, guess what? A pineapple. That is okay. Orange, apple, pineapple, coconut, banana. We can remove an element. Fruits.remove. Let's remove our apple. Our apple is gone. Coconut, orange, banana. We can pop. The pop method will remove whatever element is first, but it's going to be random though. orange coconut banana, apple coconut banana, apple banana coconut. You can clear, fruits dot clear. The elements of our set are gone. Those are a few of the more useful methods for beginners. As a summary, a set is a collection that is unordered and immutable. You can't change the values, but adding and removing elements is okay. No duplicates are allowed. Let's try that real quick. I'm going to add a second coconut. Yeah, see, we only still have one coconut. Sets may work well if you're working with constants. Maybe colors, for example. You need to find if a color is within a set. Alright, now lastly, let's talk about tuples. A tuple is a collection that is surrounded with a set of parentheses. Tuples are ordered and unchangeable. Duplicates are okay. One benefit of a tuple over a list is that tuples are faster than lists. If you're working with a collection, and it's okay if the collection is ordered and unchangeable, you might as well use a tuple because it's faster. When I print our tuple, all of these values are surrounded with a set of parentheses. Again, we have the dir function to display the attributes and methods. There's not as many for a tuple for methods. We only have count and index. Again, there's also help to display a description of these attributes and methods. You can find the length of a tuple with the length function. We have 5 elements within here. Using the in operator, we can find if a value is found within our tuple. Our pineapple is not within our fruits. So there's only 2 methods we have access to. Let's find the index of apple. Fruits.index apple. Then I will print whatever is returned. Apple is found at index 0. There is also count. Fruits.count. How many coconuts are found within our tuple fruits? Count the coconuts. Then print this. How many coconuts? We have 2 coconuts. And then again, with any of these collections, they're iterable, so you can iterate over them using a for loop. For fruit in fruits. Yep, apple, orange, banana, apple, dictionaries, changeable. Duplicates are okay. A set is unordered and immutable, but adding and removing elements is okay. No duplicates allowed. A tuple is ordered and unchangeable. Duplicates are okay, and they are faster than lists. Use tuples if you can over a list. But yeah, those are a few collections in Python. Hello everybody. Today we will be creating a shopping cart program. This program will be an exercise to follow the previous lesson on lists, sets, and tuples. The more that we practice with those collections, the better we'll be at using them. So I thought we'd create an exercise to get the hang of it before moving on. In this program, we will have 2 lists. Foods. These lists will be empty. We'll declare them but not use them quite yet. And prices. Then a total. Total equals 0. The reason that I'm not using tuples is that tuples are unchangeable. We're going to ask a user what food they would like to buy. We can't append any elements to a tuple. We're not using sets because sets are unordered. I mean, I guess technically you could, but at the end of this program, I'm going to print our shopping cart in order. So I think lists would probably be the best. We have an empty list of foods and an empty list of prices. We'll use a while loop. While true, if our condition is set to true, we'll need some way to break out of the while loop. We'll need a break statement somewhere. We'll get to that later. We will ask the user what food would they like to buy. Let's declare variable food equal to input. Enter a food to buy. To exit the while loop, you need to press Q. Q to quit. Then let's check if food is equal to Q, lowercase q, then we will break. We're not done with the program, but let's at least test it. Pizza, hamburger, hot dog, Q to quit. Okay, it looks like it works. Now what if somebody types in uppercase Q? Pizza, hamburger, uppercase Q. Well, we can't actually quit. After accepting our user input, if food dot lower method, this will take our input, make it lowercase, just for a comparison. Let's try that again. Pizza, hamburger. I'll type capital Q to quit, and that is valid. Follow food with the lower method to temporarily make the user input lowercase, just in case they type in capital Q. If the user doesn't want to quit, let's add an else statement. Else, let's take our foods, use the append method, then add whatever food the user typed in. We'll also need a price. Let's ask a user for the price. Price equals input, enter the price of, let's use an F string, a, whatever food the user types in. Pick a unit of currency. I'll pick dollars. We are working with numbers. We should typecast our input as a floating point number, since we're working with prices. So we will accept a price, add our food item to our list of foods, do the same thing with prices. Prices.append whatever the price was. And that is the while loop. Let's test this program again to be sure that everything's working. Pizza. Pizza will be $5.99. Enter a food to buy. Hamburger. Hamburgers will be $3.50. Hot dog. Hot dogs will be $1.75. I would like to quit. I will type either capital Q or lowercase q. Both will work. And we have escaped the while loop. So the while loop is now complete. Outside of the while loop, let's display our shopping cart. Let's print some decorative text. Maybe 5 dashes. Your cart. Then another 5 dashes. I will then iterate over all of the elements found within my foods list. For every food in my list of foods, let's print each food item. Let's take a look so far. Again, we have a pizza. The price was $5.99. Hamburger. The price was $3.50. Hot dog, $1.75. Q to quit. Okay, your cart. That will display the individual list items. If you would rather have these list items arranged horizontally in one line, you can add this keyword, end equals. This end keyword will replace the new line character at the end of a print statement with some other character like a space. Let's try that again. I'll try not to take too much time. Pizza, $5.99. Hamburger, $3.50. Hot dog, $1.75. Q to quit. Yeah, that's much better. We are horizontally listing all of the different items within our list. You could revert back to the vertical list if you'd prefer that. I'll keep my output like this. Then we will need to iterate and add up all the prices. For every price in prices, we do have a total variable that we declared. Let's utilize that. Total equals total plus price. Otherwise, we could shorten this to plus equals price. That would do the same thing. Then we will display the total. Print, I'll use an F string. Your total is, I'll add a unit of currency. I picked the $, whatever the total is. Okay, let's run this program one last time. Enter a food to buy. Pizza, which was $5.99. Hamburger, which was $3.50. Hot dogs, they are $1.75. Cue quit. Here's your shopping cart. I'm just going to add one new line real quick, right before we display the total. Just an empty print statement. Here are the results. Your cart, pizza, hamburger, hot dog. Your total is $11.24. All right, everybody, well, that is a shopping cart program. I thought this would be a fun exercise to follow the previous lesson on lists, sets, and tuples. And, well, yeah, that is a shopping cart program in Python. Hey, what's going on, everybody? So today I'm going to be explaining 2D lists. 2D meaning two-dimensional. You do also have the capability of creating 2D tuples. I thought today we would use 2D lists just because they're pretty flexible. A two-dimensional list is just a list made up of lists. It's really useful if you ever need a grid or matrix of data, kind of like an Excel spreadsheet. Let's create 3 lists. A list of fruit, vegetables, and meat. I'm going to speed up this video. Feel free to pause if you need to catch up. Here I have 3 lists, a list of fruit, vegetables, and meat. Each of these lists is a one-dimensional list. To create a two-dimensional list, well, you would begin by creating a one-dimensional list. Let's create a list of groceries. All I would need to do is add my individual lists as elements to the outer list, the 2D list. We have fruits, vegetables, and meats. Normally, to print a list, or your other collections, you would print the name of the list. In my list fruits, I have apple, orange, banana, coconut. To access or change one of the elements, you would type the name of the list, then use the index operator. So fruits at index of 0 is a pineapple again. With a 2D list, it's a little different. If I were to print my 2D list of groceries, we would lay out the entire 2D list flat. We have individual lists separated with a comma, all enclosed within a set of square brackets. Taking the elements found within our 2D list, I'm going to line these up kind of like this. It kind of represents a grid or matrix with rows and columns. Each individual list resembles a row. Each element resembles a column. If I were to print groceries at index 0, in place of returning one element found within one of the lists, that would return an entire row. So groceries at index 0 is my fruits list. Groceries at index 1 is my vegetables list. Groceries at index 2 is my meats list. For one of the elements found within one of the rows, you would need 2 indices. If I need the apple from the first row within my 2D list of groceries, that would be row 0, column 0. kind of like coordinates. Row 0, column 0, that would be my apple. Zero 1, which is an orange. 0 2 is banana. 0 3 is coconut. For the next row, I would set the first index to be 1. Row 1, column 0, that would be celery. I'm going to speed run this real quick just to show you all the different elements. 1 1 is carrots. 1 2 is potatoes. If we try to access 1 3, that index is out of range because we only have 3 elements within this row. So then the next row would have an index of 2. Column 0 would be chicken. 2 1 is fish. 2 2 is turkey. 2 3 is out of bounds. To access an element from a 2D list, you would need 2 indices in place of 1, because using just 1 would return the entire row, like so. Now, when you declare a 2D list, you don't need to necessarily give each inner list a name. We could do something like this. I'm going to replace using an element from a 2D. 2 1 is fish. X is out of range. 1, column 0, that would be celery. Index is out of range. Would have 2 indices in place. To access an element from a 2D list, you would need 2 indices in place of 1, because using just 1 would return the entire row, like so. Now, when you declare a 2D list, you don't need to necessarily give each inner list a name. We could do something like this. I'm going to replace these names with the rows. I'm just going to put these on a new line to make it more readable. There, that would work too. Just separate each inner list with a comma, then enclose everything with a set of square brackets. If you ever need to iterate over the elements of a 2D list, you can use nested loops. If I were to use a single for loop, let's say for every, maybe collection. For every collection in groceries, let's print what our collection is. Using a single for loop would iterate over the rows, but to also iterate over the elements found within each row, we would use a nested loop. For every food in our collection. We could do something like this. There, that would work too. Just separate each inner list with a comma, then enclose everything with a set of square brackets. If you ever need to iterate over the elements of a 2D list, you can use nested loops. If I were to use a single for loop, let's say for every, maybe collection. For every collection in groceries, let's print what our collection is. Using a single for loop would iterate over the rows, but to also iterate over the elements found within each row, we would use a nested loop. For every food in our collection, let's print what our food is. Using nested loops, we can iterate over all of the elements found within our 2D list. But I'm going to make this more organized, like that grid structure we have. I'm going to replace the new line character at the end of a print statement with a space. Then, when we exit the nested loop, I will print a new line by using just an empty print statement. There, that kind of resembles our grid structure. We have rows, and we have columns. With two-dimensional collections, you're not limited to just lists. You could create a list of tuples, so the inner rows will be surrounded with a set of parentheses. This is also valid too. Or you can make a 2D tuple. It's a tuple that's made up of tuples. You could make a tuple made up of sets. Sets are enclosed with a set of curly braces. Here we have a tuple made of sets. Use whatever is best for your own programs. Let's go over an exercise. Let's create a two-dimensional keypad that you would normally find on a phone. We have 3 data types. A list, a set, or a tuple. The elements in a set are unordered, so we can't use that. These numbers need to be in order. If we have the option, a tuple is faster than a list. A tuple is ordered and unchangeable, so we should use it if we can. And that's perfectly fine. Fine. Let's create a 2D tuple this time. I will name this 2D tuple numpad. We have an outer set of parentheses, then an inner set of parentheses for each row. We will have 4 rows. The first row will be 1, 2, 3. The second row, I'm going to put this on a new line. 4, 5, 6. The next row will be 7, 8, 9. Then the last row will be an asterisk character, then 0, then the pound sign. So numpad, in this case, is a 2D tuple. Let's use a for loop to iterate over every row. This will be the outer loop. For every, maybe row. For every row in numpad, let's begin by printing our row. So we're printing every row in our numpad, but I'd like to remove the parentheses. Let's create a nested loop for every, maybe num, for num in row. Print whatever that num is. We have one long vertical line. Let's replace the new line character at the end of our print statement with a space. Then when we escape the nested loop, let's print a new line. And there is our telephone number pad. You can see it's a grid made up of rows and columns. So yeah, that's a 2D list. Well, a 2D collection. It's a collection that's made up of collections. Then with our numpad, we made a 2D tuple. If you ever need a grid or matrix of data, a 2D collection would work perfect. And there you have it, everybody. Those are 2D collections in Python. Hello again, everybody. So today we're going to create a quiz game in Python. Let's declare all of the different collections and variables that we'll need first. We will need a tuple of questions, a 2D tuple of options. My quiz will have 5 questions, but you can add more or less questions. Then a tuple of answers. A list of guesses. We will be appending guesses to our list. That's why we're using a list rather than a tuple. A score variable, which I will set to be 0. Then question number. This variable will keep track of what number question we're on. All right, let's begin with our questions. I have 5. Here are my questions. They're all science related. Feel free to choose your own. This is what I have. How many elements are in the periodic table? Which animal lays the largest eggs? What is the most abundant gas in Earth's atmosphere? How many bones are in the human body? Which planet in the solar system is the hottest? These are the questions, but we'll need options. Let's add 4 options for every question. That's why we're using a 2-dimensional tuple. Each inner tuple will consist of 4 elements. They will be options A, D. This first element corresponds to my first question. How many elements? We have all of our different collections and iterate over our tuple of questions. They are iterable. For every question in questions, I'm going to print some decorative text. I think that's probably good. Then I will print each question we're iterating over. So let's see what we have so far. There's all 5 questions. After we display every question, I need to display every option. For every option in options. Our options is a 2D tuple. Let's add the index operator. The index is going to be our question number variable. It's a number. So at first, we're accessing options at index of 0, then 1, 2, 3, 4, 5. We will print every option in options at a given row number. Let's test this. Okay, we have some options, but all of these options are for the first question. We will need to increment our question number. So let's do that maybe here. Question number plus equals 1. That is much better. Before iterating the question number, we will ask the user for a guess. Guess equals input. Enter A, B, C, D. In case the user types in something that's lowercase, I will follow this input with the upper method to make the user input uppercase. We will take our list of guesses, use the append method, add our guess to that list. If our guess is equal to the answers tuple at index of question number, that means the user guessed the right answer. Let's increase the user score. Score plus equals 1. Then print the word correct. Correct. Else, we will print incorrect. I'll use an F string. Our answers at index of question number is the correct answer. All right, let's answer some of these questions. C, correct. Which animal lays the largest eggs? Definitely the whale, because the whale's the largest creature, right? Incorrect. D is the correct answer. What is the most abundant gas in Earth's atmosphere? Nitrogen. Correct. How many bones are in the human body? D. That is incorrect. A is the right answer. Which planet in the solar system is the hottest? Mercury, because it's closest to the sun, right? Wrong. Incorrect. B is the correct answer. We're keeping track of our answers successfully. Once we complete all the questions, let's print the results. I'm going to add some decorative text. Not necessary, but I think it would look cool. I will display the results. We will iterate over all of the answers and the guesses. Print answers. I'm going to set the ending character to be an empty string. For every answer in answers, print each answer. I will set the ending character to be a space to separate each answer. Then I'll add a new print line. Let's do this with guesses. Change answers to guesses. For every guess in guesses, print each guess. Okay, I'm going to run this again. I'm just going to make up some answers. A, B, C, D, A. Here are the correct answers. Here are the guesses. I guessed none of them right. Then we will print a score. Score equals, take our score divided by, I'm going to use the length function, then pass in our questions. How many elements are within our questions tuple? Then I will multiply all of this by 100 to give us a percentage. Then typecast this whole formula as an integer. So we're basically just reassigning our score variable. Then let's print, using an F string, your score is our score variable, then add %. I'm going to intentionally get all the answers right. C, D, A, B. Here are the answers. Here are your guesses. Your score is 100%. This time I'll try and get a few incorrect intentionally. C, 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 C. Your score is 20%. All right, everybody, well, that is a quiz game. Feel free to add more or less questions, or come up with your own questions. And that is a quiz game written in Python. Hey everybody, in today's video I'm going to explain dictionaries. A dictionary is one of the 4 basic collection types for beginners. A dictionary consists Lists of key value pairs. They are ordered and changeable. No duplicates allowed. A few examples of key value pairs could be an ID and a name, an item, and a price. But in today's example, we'll create a dictionary of countries and capitals. Let's name our dictionary capitals. Capitals equals, enclose your dictionary with a set of curly braces, much like what you do with sets. The first country will be the USA. To add a value to this key, type colon, then some other value. The capital of the USA will be Washington, D.C. Separate each key value pair with a comma, then we can add another key value pair. So the capital of India, that will be New Delhi. We'll add two more. China, the capital is Beijing. Russia, the capital is Moscow. I think that's good enough. Just as a reminder, if you would like to see all of the different attributes and methods of a dictionary, you can use the dir function, pass in your dictionary, capitals, then we'll need to print this. Here's all the different attributes and methods of a dictionary. If you would like an in-depth description of all these attributes and methods, you can use the help function. That's herp. Help. There we go. So yeah, that's just a reminder. All right, let's cover a few of the methods. To get one of the values from a dictionary, you would get the key. Type the name of the dictionary, capitals, dot get. Let's get the capital of the USA. Then we'll print it. The value associated with this key, the USA, is Washington, D.C. If I picked a different country like India, well then we would get that associated value, which is New Delhi. Another thing, if Python doesn't find a key, this is what will be returned. Let's get Japan, which is not in our dictionary. This method would return none. We can use this within an if statement. If capitals.get Japan, if a value is returned, then we will print that capital exists. Else, we will print that capital doesn't exist. So Japan is not in our dictionary, that capital doesn't exist, but Russia is. That capital does exist. That's how to check to see if a key is within our dictionary. You can use the get method. All right, moving on. Let's update our dictionary. Capitals.update. So within a set of curly braces, I will add a key, then a value. Germany, followed by Berlin. Then let's print our dictionary. I'll use a print statement. Print capitals. Yeah, and there's Germany right there. Using the update method, we can insert a new key value pair or update an existing key value pair. Let's also change one of the existing values. With our key USA, let's update the capital to be Detroit. Yeah, see, the value has been updated. The capital of the USA is now Detroit, Michigan. To remove a key value pair, you can use the pop method. Then pass in a key. Let's remove China. China no longer exists within our dictionary. It's gone. You can remove the latest key value pair within a dictionary by using the pop item method. Capitals dot pop item. With pop item, you don't need to pass in a key. Pop item will remove the latest key value pair that was inserted. Then we have clear. Capitals dot clear. That will clear the dictionary. It's pretty self-explanatory. The next few methods are a little tricky to explain. To get all of the keys within the dictionary, but not the values, there is a keys method. Capitals dot keys. I think I'm going to insert this within a variable. Keys equals capitals dot keys. Let's see what happens when we print this. The keys method will return all of the keys within our dictionary. Technically, keys is an object which resembles a list. I haven't discussed object-oriented programming yet. This is a little bit above our level. If you ever need the keys in a dictionary, you can use the keys method. One use is that we can use that within a for loop. They're iterable. For every key in capitals dot keys method, let's print every key. If at any time you need to iterate over all the keys, you can use a for loop to iterate over every key that is returned from the keys method of your dictionary. There's also the values method. To get all of the values within your dictionary, there is a values method. Values equals capitals dot values method. Then let's print our values. Like before with the keys method, the values method will return an object which resembles a list. Let's iterate and print over every value within our dictionary. For every value in capitals dot values, print every value. Here are all the values within our dictionary. This next one is probably the most tricky. It is the items method. Capitals dot items. I will assign what is returned to a variable named items. Then we will print items. Items returns a dictionary object which resembles a 2D list of tuples. It's really complicated. How might this be useful? This time we're going to use a for loop to print every key, comma, value in capitals dot items method. We have, in essence, two counters this time. I will print using an f string every key value pair. I will print every key as well as every value in our print statement. So there's our dictionary laid out. We have iterated over every key value pair. It's kind of an advanced topic, but I thought I would at least bring it up now. So yeah, that's a dictionary, everybody. It's a collection of key value pairs. They are ordered and changeable. No duplicates allowed. You have a bunch of different methods such as get, update, pop, pop item, clear. Then you can get the keys, the values, or both, which is the items method. We'll be using dictionaries in a few game programs we'll be making in the future. And well, yeah, those are dictionaries in Python. Hey everybody, today we will be creating a program to mimic a concession stand. And much like what you would see at a movie theater, we will be utilizing a dictionary to keep track, and which is the well, yeah, everybody. Today we will be creating a program to mimic a concession stand. Much like what you would see at a movie theater. We will be utilizing a dictionary to keep track of a menu item and an associated price. More or less, this is just a program to help us get used to working with dictionaries. Let's begin. We'll create a dictionary named menu. What items are on the menu? We'll need an item and a price. I'll think of some. I'm going to speed up this video. Feel free to pause if you need more time. And here's my menu, everybody. I thought of a few food items you might find at a movie theater concession stand. Pizza, nachos, popcorn, fries, chips, soft pretzels, soda, lemonade. Movie theater popcorn is really expensive for some reason. Okay, we have our menu. A user is going to select specific keys from this menu. Depending on what the key is, we can get the associated value to calculate a total. To keep track of the user selected items, I will create an empty list named cart. I will also declare a variable named total to keep track of the total. We need to lay this dictionary down flat to display it to a user. Well, we do have the items method of a dictionary, which we covered in the last video. For every key value in our dictionary menu dot items method, the items method of our dictionary will return a key and a value during each iteration. I'm simply going to print every key and value. I'll use an F string. I will print every key, colon space, then a value. Let's take a look so far. Here's our menu. I'll make a few changes. The price will be in dollars and cents, but feel free to pick your own unit of currency. I'll precede my value with the dollar sign. Then using a format specifier, I will display 2 decimal places, 0.2f. That's better. I will line up all the keys. After the key, I will add a format specifier, then allocate 10 spaces. Yeah, look at that. It's all lined up now. Before and after displaying our menu with this for loop, I will add some decorative text. Let's say menu. Then outside of the for loop, I'll display a bunch of dashes. Yeah, look at that. Let's move on to the next step. We will ask a user for some input. What item would they like to buy from the menu? While our condition will be true. If our condition is set to true, we'll need to break out of this loop one way or another. We will ask for some user input. Food equals input. Select an item. Q to quit. If food is equal to a lowercase q, then we will break. Let's test it. Select an item. Pizza, nachos, soda, Q to quit. Yeah, it works. Okay, what if the user types in capital Q? Well, we can't escape the while loop. If a user types in capital Q, we're assuming that they would like to quit. When we accept our user input, I'm going to add dot lower method. This will take our user input and make it all lowercase. So we should be able to acknowledge any uppercase letters. Yeah, it works. Cool. Let's add an else if statement. What if a user types in an item that's not on our menu? Well, there is a get method of dictionaries. If menu.get, pass in our food, which is user input. If the user selection is not within our menu as a key, it will return none. So we can use that. Else if menu.getFood is not none, then we would like to append that food item to our cart. Cart.append our food item. So outside of the while loop, I'm going to print our cart temporarily, just to test it. Okay, select an item. Pizza, soda, pretzel. How about a potato? Q to quit. We have our pizza, soda, and pretzel, but not our potato. We don't want that in our cart because that's not on the menu. Yeah, you can just add that line. Else if menu item dot get food is not none. That will complete our while loop. Let's calculate a total. For every food in our cart, let's take our total variable, set this equal to total plus, then we need a value associated with a key, plus menu dot get method, get the food item found within our cart. But I'm going to shorten this to total plus equals menu dot get the value associated with this food in our cart. I will also display that food item. Print food. I'm going to avoid printing our food item on every line. I will set the ending character in our print statement just to be a space. Okay, let's see what we have so far. I would like popcorn, soda, pretzel. Cue to quit. Popcorn, soda, pretzel. Then we will display the total. I will print a new line. Print. I'll use an F string. Total is, add a unit of currency, total. I'll add a format specifier, .2f to display 2 decimal places. I'm going to add 1 line of decorative text. Let's copy maybe this. All right, let's test it out. Select an item. Popcorn, pretzel, soda, potato. Cue to quit. All right, here's our cart. Popcorn, pretzel, soda. We did not include the potato. That was not found within our dictionary. The total is $12.50. Well, there you have it, everybody. That is a concession stand program. The point of this program was to help us get used to working with dictionaries. A dictionary is a collection of key value pairs, such as an item and a price. And yeah, that's a concession stand program in Python. Well, hello again, everybody. It's me. In today's topic, I'm going to show you how we can generate some random numbers in Python. Then at the end of this video, as an exercise, we're going to create a number guessing program. Let's begin. We will be importing the random module. Type import random. The random module gives us access to a lot of useful methods involving random numbers. For a comprehensive list, you can use the help function, pass in the random module, and then we would want to print this. Here's what we all have access to. We have a shuffle method, set state, seed, sample, random range, random int, random bytes, and there's a ton of others, but we'll discuss a few of the more useful methods for beginners. For a random whole integer, maybe you're rolling a 6-sided dice. You would type the name of the random module, dot, then a method. For a random whole integer, type rand, int, add a set of parentheses. Within the set of parentheses, you will list a range. If I'm rolling a 6-sided dice, I would like the numbers 1 through 6, 1 comma 6. Then I will assign what is returned to maybe a variable. Print whatever my number is. My random number is a 4, 3, 1, 4. Alright, I tend to play a lot of Dungeons & Dragons. We use polyhedral dice that have more or less than 6 sides. There is a 20-sided dice. For a random number between 1 and 20, I would set the range to be 1, comma 20. Here I rolled a 16, and a 7, and an 8. Within the randint method, you can place variables as well, as long as they contain numbers. I will create a variable named low. I'll set that equal to 1. And a variable named high. I will set that to be 100. I will replace the numbers with my variables that behave as numbers. Give me a random integer between my low variable and high variable. So between 1 and 100 in this example, I have rolled a 75. Now an 88. If you need a random floating point number, you can use the random method. Random.random. Then let's assign this to a variable. Number equals the random method of the random module. That would return a random floating point number between 0 and 1. You can pick a random choice from a sequence. In the future, we're going to create a game of rock, paper, scissors. Let's say we have a tuple of options. Options equals rock, paper, scissors. We are accessing the random module, dot, then use the choice method. Place your sequence within the choice method. Give me a random choice from options. I will store this within a variable. Let's say option equals random choice from my options. Then I will print the option. Our computer has generated scissors, paper, rock. So the choice method is a great use for games, if you ever need a random element. Now there's also shuffle. This time maybe we have a deck of cards. Cards equals, I guess I'll use a list this time. There's one thing we want to check. Python number guessing game. Select a number between 1 and 100. Enter your guess. What if somebody doesn't type in a number, like they type in the word pizza?
we should let the user know that that's an invalid guess. We'll write the following if statement. If our guess use the isDigit method, if our guess is a digit, a number, then we will execute any code underneath this if statement. For the time being, I'll write pass. Once we get a guess that is a digit, we need to convert it to a number, because when you accept user input, it's a string. We will reassign our guess equal to typecast our guess as an integer. Then increase the number of guesses by 1. Guesses plus equals 1, because we have already made one guess. Here's another scenario. What if somebody guesses a number outside of this range, like 1 kajillion? Well, we should give a warning that that guess is invalid. If our guess is lower than the lowest number, or our guess is greater than the highest number, we will print the following. That number is out of range. And I will reprompt the user. Please select a number between the lowest number and the highest number. Let's perform a test run. I will guess 1 kajillion. That number is out of range. Please select a number between 1 and 100. If our guess isn't less than our answer, and our guess isn't greater than our answer, that means we must have the correct answer. Within an else statement, we will print, I'll use an F string, correct. The answer was, insert our answer variable. Then print Python number guessing games, 50, 60.
Hey everybody, random module works. Let's begin by importing the random module. We will create some options. We will use a tuple. We're not going to be changing the options, so a tuple would be better than a list. We have 3 options: rock, paper, or scissors. I'll create a variable named player to store the player's choice. For now, I'm going to set this to be none, as well as a computer. Our computer is going to pick a random choice from these options: rock, paper, or scissors. In order to do so, we can use the choice method of the random module. random.choice. Pick a random choice from options. Let's have the player enter in some input. Enter a choice. Rock, paper, scissors. Then we will display the player's choice and the computer's choice. I'll use an F string. Player, :space. The variable player. Let's copy that, paste it, then change player to computer. Let's see what we have so far. Enter a choice, rock, paper, scissors. So I pick rock, the computer picks scissors. Let's try it again just for good measure. I pick paper this time. The computer picks scissors. I pick scissors. The computer picks paper. Okay, we know that the computer is successfully picking a random choice from our options. Now, what if the player picks something that's not within this tuple, such as the gun? Well, we would want to stop that, right? We need the user to pick a valid option. Only rock, paper, or scissors. I think what we'll do is that when we accept user input, let's place it within a while loop. So indent this line. While, this condition is going to be kind of weird. While our player variable is not in our tuple options. Let's try this again to see what happens. I pick the gun. Enter a choice. All right, well, if I can't pick a gun, how about a sponge? Well, I can't pick that either. Rock? That works. Our condition is while the player variable is not found within our options. If the player doesn't pick one of these options, this while loop will continue forever. Once we pick something that's within our options, we then escape the while loop. Let's check some win conditions. Now, if the player is equal to computer, that means it's a tie. I will print it's a tie. I'll add a few else if statements. Else if the player is equal to rock, I'll use the and logical operator, and the computer is equal to scissors. That means you win. Let's print you win. Let's add another condition, else if the player picks paper and the computer picks rock, then you also win. You win. Else if the player picks scissors and the computer picks paper, then we will print you win. Else, if the player's choice is not the same as the computer's, and we don't meet any win conditions, that must mean we lose. Print you lose. Let's see if this works. Enter a choice, lose. I'll pick paper. You win again. scissors. I need to stop pick equals true. I will play all of to explain something. The reading, that's simpler. Let's say running is normally. Let's do so right about here. You lose. What if the user would like to play again? Let's place all of this code within a while loop. Let's do so right about here. Now, I'm not going to write while true like I normally do. This time, I'm going to create a variable. Let's say running is our game running. I will set that to be true. While running equals true. Or we could shorten this to just while running. That's simpler. I will place all of this code within the while loop. To mass indent some code, just highlight all of the code, then press tab. Hey everybody, this is Bro from the future. I forgot to explain something. The reason I'm not setting the condition of my while loop to be true is that if you have a lot of code within a while loop, it can be really difficult to find where the break statement is. If I set my condition to be a Boolean variable such as running, it's a lot easier to find any instance where I use this variable. If I were to highlight it, we can see that running is found down here. If I need to change any instance of this variable and rename it to something, you can refactor. Let's rename running as maybe playing. Then I will refactor. So my variable running is now playing, and that change was made down here too. So it's a coding preference. Every time we start a new game, I down here name running as maybe playing. Then I will refactor. So my variable running is now playing, and that change was made down here too. So it's a coding preference. Every time we start a new game, I will reset the player as well as the computer. Let's move these two lines into the while loop at the beginning. So when we start a new game, we will reset the player. The computer will pick a new random choice. So let's see what we have so far. Rock. I pick rock, the computer picks rock. It's a tie. Then we have to play again. So paper, you lose. Scissors, it's a tie. Now what if we would like to escape the while loop? After our win conditions, I'm going to create a temporary variable. Let's name this play again. Then we will ask for some user input. Play again, question mark. Y/n, meaning yes or no. If the user types in something that's capital, I'm going to use the lower method to make it lowercase. So if our play again variable is equal to y, we would like to escape. What I would like to do is I would like to see if the player types in something that's not y. I will precede this condition with the not logical operator. If the user does not want to play again, then let's take our Boolean variable, running, normally it's true, and set that to be false. Running equals false. And that means we will escape the while loop. Once we escape the while loop, I will print, thanks for playing. Now I'm going to change this momentarily. I just want to test it. Rock, play again, yes. Paper, play again, yes. Scissors, you lose, play again, nope. Thanks for playing. This is entirely optional. I try and create as few variables as possible. I would personally rather avoid creating a variable here. Another way in which I could write this is that I can get rid of this variable. Let's move if not in front of the input and follow our input here, then use the comparison operator. Then add a colon. If the user's input, after making it lowercase, does not equal a y for yes, set running to be false. So that should work the same. Rock, play again, yes. Enter a choice. Paper, play again, no. Thanks for playing. This line would work the same, but it's a little more complex for beginners to read. Or you can use the other method that I showed you. All right, everybody, well, that's a game of rock, paper, scissors. Hello everybody, today we will be creating a dice roller program in Python. We will be utilizing some ASCII art. I'll post all of the ASCII art that we'll need in the description of this video. this video, you can copy and paste. Hello everybody, today we will be creating Let's copy them. I'll add them to a comment. Then we can delete this line. These are the Unicode characters we'll need to build some ASCII art, some dice. Each die will be made out of 5 lines. Let's begin with the first. We'll need a left corner, 9 dashes, then the right corner. For the second line, copy this vertical bar, add 9 spaces, then a vertical bar. We can copy this whole line, paste it 2 times. Let's use the left bottom corner, add a 9 of these dashes, then the bottom right corner. And here's a basic box shape. Depending on what the number die is, we can add one of these bullet points. For a 1, we can add that right to the middle. So that's good for now. We'll delete this later. Let's create a dictionary. I will name this dictionary Dice Art. Our dictionary is made out of key value pairs. So the keys will be the numbers 1 through 6. Beginning with 1, the value will be a tuple. It's a dictionary made out of key value pairs where the value is a tuple. Within the tuple, let's add these lines, each separated with a comma. I'm going to format these so they form a box shape. Let's take our bullet point, place it right in the middle, then add a comma to the end of this key value pair. That is the first key value pair. Let's copy all of this, paste it again, change 1 to 2. Let's move this bullet point. We need 2 bullet points, about right here and here. Let's repeat this process for keys 3 through 6. The total, I'll set that dice. This will be some input. How many dice? Then typecast the input as an integer. We don't want somebody to write, 2.5 dice. You can't roll half a die. To generate a random number, you can use the randint method of the random module. We need a random number between 1 and 6. Then we need to append this number to our list of dice. Dice.append. Then we can move this line to within the append method. We need to do this a number of times depending on how many dice the user enters in. We can place this line within a for loop. For every die in our range, number of dice. This will be a number. Let's print our list of dice to see what numbers we have in here. How many dice? I would like 5 dice. 5, 3, 3, 4, 6. Okay, we know that that works. Let's calculate a total. We'll need to iterate and sum all of the elements within our list. We can do that with the for loop. For every die in our list dice, take our total variable plus equals the current value within our dice. Then we will print a total. I'll use an F string, total colon space, our total variable. Let's see what we have so far. How many dice? I would like 5 dice. Our total is 19. Now between these two for loops, we will display our ASCII art. The easiest way would be to create some nested for loops. The outer for loop will be in charge of the number of dice. For every die in our range, number of dice. The inner for loop will be in charge of printing every tuple. For every line in, then to get a value in our dictionary, we would type in our list dice, take our total variable plus equals the current value within our dice. Then we will print a total. I'll use an F string, total colon space, our total variable. Let's see what we have so far. How many dice? I would like 5 dice. Our total is 19. Now between these two for loops, we will display our ASCII art. The easiest way would be to create some nested for loops. The outer for loop will be in charge of the number of dice. For every die in our range, number of dice. The inner for loop will be in charge of printing every tuple. For every line in, then to get a value in our dictionary, we would type the name of the dictionary, dice art, then use the get method. What are we getting? We're getting a value at a given key. Let's take our list of numbers, dice, at index of die, our counter. Depending on what the user types in for the number of dice, die will begin at 1, then increment. Within the inner for loop, we will print the line. So let's take a look. How many dice? I would like 3 dice. And here's our ASCII art. 6 plus 2 plus 4, that equals 12. If you would prefer, we can display all of these dice on a single horizontal line instead of one vertical line. It's a little more tricky though. If you would prefer that approach, let's turn this chunk of code into comments. We will write this nested loop a little different. So each tuple is made up of 5 elements, right? So if we're printing a horizontal line, let's say we roll the numbers 1 through 3. We would first need to display this line of the first dice, then the first line of the second dice, then the first line of the third dice. The outer loop, we would display the second line of the first dice, the second line of the second dice, the second line of the third dice. So it's a little more complex. Let's create an outer loop that will iterate 5 times. For every line in range 5. Then the nested loop will be for every die in dice. How many dice do we have with in dice. How many dice do we have within our list? We will print. We're going to get one of the values found at one of the numbers that we roll. Take our dictionary of dice art, dot get, then a number 1 through 6. That will be the value found within our list of dice. Get the current die. Remember that this is a number 1 through 6. We would then need one of the elements found within our tuple. So get the first line, then the second line, third, fourth, fifth. So let's add the index operator. Place our counter of line within the index operator. Let's see what we have so far. We need to add one more thing. How many dice? 3. This is an abomination. There's one more change we need to make. At the end of our print statement, let's set the ending character to be an empty string. And that should fix that. How many dice? 3. Okay, we're getting better results. Then when we escape the inner loop, we will print a new line. How many dice? 3. And there we are. 3 plus 6 plus 1 is 10. All right, everybody, so that is a dice roller program. It is kind of complex, but I thought this might be a good exercise. If you would like a copy of this code, I will post all of this in the comments section down below. And well, yeah, that's a dice roller program in Python. Hey everybody, today I need to explain functions. Think of a function as a block of reusable code. To invoke a function, you place a set of parentheses after the function name. To invoke it, here's a Scenario. I need to sing happy birthday 3 times. I know it's a weird example, but it makes a lot of sense. Just trust me on this. If I need to sing happy birthday 3 times, I would write something like this. I'm going to create my own version of the happy birthday song. This is one verse. If I need, without using functions, I could either repeat this code, or maybe place it within a loop. So here's my happy birthday song 3 times. But there's a better way of handling this that doesn't involve repeating our code or using loops. What if I could write this code once, then reuse it whenever I need to? That's where functions come in. To define a function, you would type def, then a unique function name. Let's name this function the happy birthday function, add a set of parentheses, a colon. Any code that belongs to the function, you'll want to indent underneath. Then to invoke this function, I would type the name of the function, happy birthday, add a set of parentheses, and that's it. When you invoke this function, you will execute this code once. If I need to execute this code 3 times, I would just call it 2 more times. Happy birthday, happy birthday, happy birthday. To invoke a function, you type the function name, then add a set of parentheses. I like to think of the parentheses as a pair of telephones talking to each other. You call a function to invoke it. Hey, happy birthday function, execute your code. With functions, you are able to send data directly to a function. Using what are known as arguments, you can send values or variables directly to a function. Place any data within the set of parentheses. I'll send my function a first name. Any data you send a function are known as arguments, but you need a matching set of parameters that are in order. What exactly is the data we're sending in? Well, it's a name. I will add one parameter to my happy birthday function. I will name this data name. A parameter is kind of like a temporary variable that's used within a function. I'm going to replace this instance of u with a name. I will use an f string, replace u with a placeholder. I will add my parameter name. So happy birthday to bro. We could pass in some other names. What about Steve and Joe? Here we are. Happy birthday to bro. Happy birthday to Steve. Happy birthday to Joe. When you invoke a function, you can send more than one argument. Let's send an age this time. I'll send 20, 30, and 40. But when I run this, we have an error. We're passing in 2 arguments, but our function is set up only to take 1. I would need a matching number of arguments. To invoke this function, we will need 2 parameters. We have a name and we have an age. Then let's use this age. You are, let's make this line an f string, age, years old. Let's try that again. Happy birthday to bro. You are 20 years old. Happy birthday to Steve. You are 30 years old. Happy birthday to Joe. You are 40 years old. When you invoke a function, you can pass in some data. Those are known as arguments, but you'll need a matching set of parameters. The order does matter. Let's see what happens when I switch these 2 parameters. Age, then name. Happy birthday to 20. You are bro years old. Happy birthday to 30. You are Steve years old. Happy birthday to 40, you are Joe years old. So the position of the parameters does matter. Same thing goes with the arguments. You also could name these parameters something unique. Maybe X and Y. Happy birthday to X, you are Y years old. That's also valid. Let's try another example. I'm going to create a function to display an invoice. There will be 3 parameters. A username, an amount, and a due date. Let's print hello. I should make this an f string. Username. We'll use another f string. Your bill of amount Let's precede this placeholder with the unit of currency. I will also add a format specifier. Point2f is due on our due date, whatever that parameter is. To invoke this function, we will type the function's name, add a set of parentheses, a username, an amount, and a due date. Let's make up some username. An amount, I guess $42.50. I'm just making up a number here. Then a due date. The 1st of January, I guess. Here's my invoice. Hello, bro code. Your bill of $42.50 is due on January 1st. Let's change these arguments. Joe Schmo is the username. He owes $100 and 1 penny. Due on the 1st of February. Or January 2nd, depending on how you read dates in your region. Hello, Joe Schmo. Your bill of $100.01 is due on 1/2. That's another example. Now we need to explain the return statement. Return is a statement that is used to end a function and send a result back to the caller. Here's an example. We have a variable z. Z will equal, we'll invoke a function to add two numbers together, such as the numbers 1 and 2. When we invoke a function, we can send some data back. After adding 1 and 2, we will send the result, which would be 3. Then this value can be assigned to a variable. Then we can print whatever z is. So let's create some functions. Let's create a function to add two numbers together. The parameters will be x and y. Let's say z equals x plus y. Then we will return our value z. So I'm not going to print z directly right now. Let's subtract x and y. Subtract z equals x minus y, return z, multiply x times y, then divide. X divided by y, return z. Let's invoke our add function, pass in two numbers, 1 and 2. Then I'm going to print the result. After adding these two numbers together, the result is 3. What about subtract? Subtract 1 and 2. The result is -1. Multiply. The result is 2. Then divide. 1 divided by 2 is 0.5. After we resolve this function, a value is returned. Just imagine that after we finish this function becomes whatever is returned, 3. This function becomes -1. This function becomes 2. This function becomes 0.5. Let's write something a little more complex. We will create a function to create a full name. Create name. We'll need two parameters for a first name and a last name. I'll name these first and last. What do we want to do with this function? Let's capitalize the user's first name. First equals first dot capitalize method. Then do the same thing with the last name. Last equals last dot capitalize. Then I'm going to return the user's first name plus their last name. Then I'll add a space in between their first and last name. This is also valid. Outside of the function, let's create a full name variable, then invoke the create name function. So this function is going to capitalize the first and last name for us. I'll type in my first name, all lowercase, same thing with my last name. Then let's print our full name. And here's my full name variable. We sent our function some arguments. We have some parameters set up. We took those values, made them uppercase, then concatenated these strings together, then returned them as a single string. Let's try this with a different name. SpongeBob SquarePants. SpongeBob now has a full name. The first and last names are now capitalized. Using a return statement, you can return some data back to the place in which you call a function. Well, everybody, that's a function. It's a section of reusable code. To call a function, you type the function's name, add a set of parentheses. You can send a function some data, which are known as arguments, but you'll need a to the back. Hey everybody, today I'm going to explain default arguments. Default arguments are a default value for certain parameters. The default is used when that argument is omitted when you invoke a function. In the last topic, we discussed positional arguments. Today we will be examining default arguments. Then in future topics, we'll examine keyword and arbitrary arguments. Let's begin. Let's define a function to calculate net price. There will be three parameters: an original list price, a discount, if there is one, and sales tax. We will return a net price, and here's the formula: list price times 1 minus list price is omitted when you invoke a function. Here's data. You'll get more practice with those. Are a default value for certain parameters. The default is used when that argument is omitted when you invoke a function. In the last topic, we discussed positional arguments. Today we will be examining default arguments. Then in future topics we'll examine keyword and arbitrary arguments. Let's begin. Let's define a function to calculate net price. There will be three parameters: an an original list price, a discount, if there is one, and sales tax. We will return a net price, and here's the formula. List price times 1 minus our discount percentage times 1 plus our sales tax. Maybe I'm buying a PlayStation 5 for $500. I will pass in $500 for the list price. Well, I can't actually execute this function without also passing in an argument for discount and tax. Perhaps the discount is 0 and the sales tax is 5%, 0.05. Well, this would work, and I should probably put this within a print statement so you can see it. There we are. My total is $525. The list price of $500, no discount, and 5% sales tax. Now suppose that maybe 90% of the time when we're executing this function, most of the time discount is 0, and our sales tax is almost always the same. What we could do to make this function a little more flexible is to set these two parameters to have a default value. In place of sending in 3 arguments, we can pass in 1, then set our discount and our tax to have a default value. So I will set discount to be 0. It would work. $2 sales tax. Total is functions more tend to be consistent. Tax defines. With this thread that's running the program sleep, you can access the time module's sleep method, pass in 1 for 1 second. Then outside of the for loop, let's print the word done. To invoke this function, I need to pass in 2 arguments, a start time and an end time. Also, we'll have a default value. Starting, we'd like to start at 0, but we'll need to pass in an ending amount of seconds. When do we want to stop? That works the same. But now we do have the option of starting at a different number. This time, let's end at 30, but we will begin at 15. I'll speed up the video. Default argument to use this. And well, yeah, hey friend, then next we'll do display a first name and hello, the last name. We're currently using position these around. Set pre equal square pants. Then with these keyword arguments, the order last name. If you're mixing and matching positional arguments and keyword arguments, you want to be sure that the positional arguments are first. So if I was to move the string, our greeting, to the end, well, this technically wouldn't work. We have a syntax error. Positional arguments follow keyword arguments. So make sure any positional arguments are first before using any keyword arguments. 2 helpful benefits of using keyword arguments is that it helps with readability, and the order of the arguments doesn't matter. We know what this argument is, as well as these 2. Title, last name, first name. Let's say we have a first name and a last name. John, like first to clarify, and follow our print as a space. Print statement. In place of setting it to be a space, we have some numbers. Another one is separate that's found within the print statement. The numbers 1 through 5. I can use the separate keyword argument, then separate each of these strings with a given character or characters. I will separate each of these strings with a dash. A lot of built-in functions, such as the print function, they have some keyword arguments you can use. Let's go over an exercise now. We're going to create a function to generate a phone number, but we'll need to pass in a country code, area code, the first 3 digits, and the last 4 digits. Let's define this function as define get phone to get a phone number. We have a country code, area code, first meaning first few digits, then last meaning last few digits. We will return an F string. We will place our country code first, dash, then our area code, dash, the first few digits, dash, the last few digits. My phone number, phone num, equals, I will invoke the get phone number function we just created, but we'll need a country code, an area code, First few digits, then last few digits. And remember, the order doesn't necessarily matter. Usually I try and be consistent with the order of the parameters. Make up a phone number. I'm in the United States. My country code is 1. Area code 123. The next few digits will be 456. The last few will be 7890. Then let's print this phone number. Print phone num. And here's my phone number. Although you can change it up based on how you do phone numbers in your country. This is typically how you would see a phone number in the United States. Alright everybody, so those are keyword arguments. They are just arguments preceded by an identifier that matches the name of a function's parameters. It does help with readability, and the order of the arguments doesn't matter. When invoking a function, it could be helpful to identify some of these arguments. And well everybody, those are keyword arguments in Python. Hello friends, it's me again. Today I need to explain arbitrary arguments. Arbitrary meaning a varying amount of arguments. We don't know how many arguments the user is going to pass in when they invoke a function. To accept a varying amount of arguments, developers tend to use these parameters of args and kwargs. Args means arguments. Kwargs means keyword arguments. You would want to prefix each of these parameters with the unpacking operator, which is an asterisk. When you invoke a function that has args or kwargs as parameters, you will pack all of those arguments into a tuple if it's args, or a dictionary if the parameter is kwargs. Let's go over an example. I will create a function to add two numbers together. Define add function. There will be two parameters, a, comma, b. All I'm going to do is return a plus b. I will invoke this function, pass in two arguments because we have two parameters set up, 1, comma, 2. Then I'm going to print the result. Big surprise there, my function returned 3. Alright, well, what if I would like to pass in 3 parameters this time? Well, I can no longer use this function. The add function takes 2 positional arguments, but 3 were given. I could modify this function so that it could accept a varying amount of arguments, any amount. I'm going to replace the parameters with asterisk, then the word args, meaning arguments. So when we use the unpacking operator, what's going to happen now is that with the arguments that we pass into this function, we will pack them all into a tuple. And if you don't believe me, let's test it. I'm going to print the type of args. Then I'm going to remove this print statement for now. My parameter args is a tuple that I could work with. We can use the built-in methods of this tuple, or we could iterate over it. I'm going to iterate over this tuple. For every arg in args, For every argument in arguments, what we'll do is create a variable named total to keep track of the total. Total plus equals the current arg that we're iterating over. Then at the end, I will return the total. Let's print the result. Print, add these three numbers together. There we are. My total is 6. Then we can pass in any amount of arguments. 4 this time, maybe 5, or even 1. With my parameter args, you can change this name to something else, like nums, meaning numbers. For every num in nums, total plus equals num. This would work too. The name of the parameter isn't as important as the unpacking operator. This would be like nums, meaning numbers. For every num in nums, total plus equals num. This would work and can vary. Let's try a different example. Name. We will accept a varying amount of arguments. Use the unpacking operator, then follow the unpacking operator with the unique parameter name. For every arg in args, let's print each argument, then replace the ending character of my print statement with a space. Now, sometimes people can have a varying number of names in their full name. There can be a first name, middle name, last name, maiden name, a title, etc. So I'm going to pass in just a first name and a last name. SpongeBob SquarePants. If I need to add a middle name, I can do that. SpongeBob Harold SquarePants, or a title, Dr. SpongeBob Harold SquarePants. The third. Yeah, as I was saying, with the unpacking operator, followed by a unique parameter name, you can pack all of these arguments into a tuple, which you can use within this function. Now let's discuss kwargs. You use kwargs. A city, what country? We have a state. I'm Michigan. Just to make this look better, but you do dictionary. How to build to iterate over the dictionary. For the keys, let's change the keys method. For both, you could say .items method key. Here are the keys. For both, args dot print every key value in kwargs dot items method. Print every key. Actually, let me turn this into an F string. Print you. Pass in a varying apartment equals 100. Argument of apartment was packed into a dictionary along with all of these other keyword arguments. So that's kind of nice. We can pass in a varying amount of keyword arguments. Let's cover an exercise. We're going to use both args and kwargs together. We will print a shipping label. Define shipping label function. The parameters will be both args, comma, kwargs. Then just for now, I'm going to write pass, just so that this program will work for now. We'll fill in the shipping label function momentarily. When we invoke the shipping label function, we will first pass in any positional arguments, followed by keyword arguments, and it won't work the other way around. I'll prove that in a little bit. So let's say we have Dr. SpongeBob SquarePants the third. Then I'll add my keyword arguments. I'm going to put this on a new line. Street equals 123 fake street. Apartment equals 100. City equals Detroit. State equals Michigan. Zip equals 54321. When we invoke this function, we have a mix of arbitrary positional arguments and designed to accept both. But if we have each arg in args, let's print each arg. Then I will change the ending character of my print statement to be a space. Here's the name of the user who we're shipping something to with the shipping label function. I will print a new line. Then we will iterate over all the keyword arguments. For every value in my dictionary quargs dot values method, I will print each value. Then I will change the ending character of my print statement to be a space. All right, it's not looking too bad so far. If you were to remove some keyword arguments or some positional arguments, this should work still, which it does. I'm going to change the format of this address slightly. Let's add our street on one line, then the city, state, and zip code on the next line. Let's get rid of this for loop. To print the street, I'm going to print, use an f string, add a placeholder, quargs.get method. I'm going to get the street key. With this get method, you'll probably need to place them within single quotes. The city quargs, then quargs.get. What doesn't have what if you use 1000 if? I'll add the numbers 1 through to an iterime category. Today I got 54321. Pass in a varying amount of arguments. Set up your parameter to be 4321. All right, everybody, those are arbitrary arguments. When you invoke a function, you can pass in a varying amount of arguments. Set up your parameter to be args for a varying amount of non-keyword arguments, or quargs for a varying amount of keyword arguments. You can set up both in your parameters, which we did for this exercise. And well, everybody, those are arbitrary arguments in Python.
Hey everybody, so today I gotta talk about iterables in Python. An iterable, it's a category. Any object or collection that can return its elements one at a time is considered an iterable. If an object or a collection is considered an iterable, then it can be iterated over in a loop. For example, let's create a list of numbers. Numbers equals a list. I'll add the numbers 1 through 5 to keep it simple. Lists are considered iterable. We can use them within a for loop, one at a time. Something like blah blah blah. You know, this would work, but other people looking over your code might not understand what a blah 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 is, and I don't blame them. Each element that we're given from our iterable, the name should be descriptive of what we're given. Or you might see item. For every item in numbers, print each item. That's also a good choice. Now, you could even iterate backward. So take our 5-4 function, new line to the even add multiple, get the numbers of Anna. So a free and the type in your full name. Is not reversible. We'll create channel name. I will set. Last we have end to be a space. Last we have dictionaries with space. A new line. I will set the keyword. I kind of like key, the dictionary Q or 3 dictionary key. Both will be given both a key and a value. Make sure that the value and the key is separated with a comma. Let's print each key followed by the value separated. You're going to use the items method. Return all the values of the bill of your area value. As one, you're going to give rated to once print. Okay, cancels in it tos once in a print 3. They're about membership operators in Python. They are the able is going to return a boolean. Insert r as z us to see otherwise false. So it does the opposite of in. Guess a letter in the secret word. Is there an E? There is an E. Is there a Q? Q was not found. Depending on the statement you're trying to write, you can use either in or not in, whichever makes more sense in that context. Let's go over another example. We were searching for a value or a variable found within a string. Let's try a set. Example and of a input. Let's student. If we don't string, not a student. If I search for him, well, Larry was not found. Let's go over one last. Well, Larry was not as great as B, and Patrick. Patrick's grade is D. But Larry is not a student. If I search for him, well, Larry was not found. Create a variable. Check if at email. Invalid email. That email is also invalid. In this example, we're checking two conditions. If this value is found within this sequence, and this value is found within this sequence. Alright everybody, so those are membership operators, in and not in, within a sequence. In something that's iterable, so let me give, we will append to. We have an expression for value in iterable, and optionally we can check a condition. We'll do this in exercises later on in this topic. We'll begin with for every value is going to, we have the number mention. One number, so 10 times 10 list coconut for our iterables fruits. And this does work too. Each for every fruit in our list of fruits, return the first character of each string, A, O, B, C. Now we'll work with conditions. Numbers will be on this condition negative nums. For every num in numbers, check this condition. Check to see if num is less than 0. If so, return that number. Let's print our list of negative numbers. -2, -4, -6. Let's check to see if there's any even.
doesn't divide by 2 evenly, then we'll print our 79 or
code if a value matches a case. The benefits of using a match case statement is that they're cleaner and the syntax is more readable. In this sample program, I have a function. There is one parameter, a day. In this sample, odd numbers equal positive. We're following this formula. I like to begin with the for value in iterable portion. For every fruit in our iterable of fruits, what do we want to do? Well, let's take each fruit, use the built-in upper method to make it uppercase. Then I'm going to print my list of fruits. Each string in this list is now all uppercase. You could even cut down on one of the steps. With our iterable of fruits, I will place this list. And this does work too, although I do find this a little more difficult to read, but you can take either option. How about instead of making each string uppercase, we'll take the first letter of each string, then put it within a new list. So let's take each fruit at index of 0, that will give us the first letter. We'll place it within a new list of fruit chars, meaning characters. Here's the result. A, O, B, C. For every fruit in our list of fruits, return the first character of each string. A, O, B, C. Now we'll work with conditions. We'll create a list of numbers, both negative and positive. Numbers equals, let's say 1, -2, 3, -4, 5, -6. We'll create a list comprehension to create a new list where all of the numbers are positive. Our new list will be positive 4. We can just read for more else if grades equals, again follow this formula, for every grade in grades, check our condition. If our grade is greater than or equal to 60, we will return the current grade. Then let's print our list of passing grades. That will give us 85, 79, 90, and 61. All of these grades are greater than or equal to 60. Alright everybody, so that is a list comprehension. It's a concise way loops. Value matches a case. The benefits of using a match case statement is that they're cleaner and the syntax is more readable. In this sample program, I have a function. There is one parameter, a day. Day will be a number, ideally a number 1 through 7. Depending on this number, we'll return a string corresponding to the day of the week. If day equals 1, then it is Sunday. 2, it is Monday, all the way up to 7, where it will be Saturday. I do have an else clause if we pass in something that's not valid, like pizza. Pizza is not a day, but it really should be. Not a valid day. A cleaner and more readable alternative is to use a match case statement instead of many else if statements. Here's how. I'm going to take my if and many else if statements and enclose them within a match case. Match case. The case is going to be the value we're examining. The case will be day. Colon. We're going to examine our value of day against matching cases. We're going to replace if day equals with the following, just simply case. So let's do that with each of these statements. If you have an else clause, you're instead going to have a case of underscore. An underscore in a match case statement is a wildcard. We will perform this case if there are no matching cases. This case would function as the else statement. Here's what we're working with now. If I pass in 1 and return the day of the week, we would get Sunday. 2 would be Monday. 3, Tuesday. 7 is Saturday. And then let's try that day of pizza. That is not a valid day. A match case statement is an alternative to using many else if statements. I find this much easier to read than the many else if statements. Both would technically function. Let's go over a second example. We will create a function of is weekend. We have to pass in a day. This time our day is going to be a string, such as Monday. The value for each case, instead of a number, is going to be a string. If our day matches a case of Sunday, let's return, how about a boolean of true? We're checking to see if it's the weekend. If our day is equal to a case of Monday, then we will return false. Let's do this with the other days. I'm going to fast forward the video. We will call the function of isWeekend, then pass in a day of the week, such as Monday. So is Sunday the weekend? That is true. Monday? That is false. Saturday? That is true. And we do have a wildcard case if there are no matches. Is pizza a day of the weekend? That is false. There is a way we can modify this match case too. We tend to be repeating ourselves a lot. The days Monday through Friday all return false. We're going to use the OR logical operator, which is represented with a vertical bar. If the case of Saturday or Sunday return true, if the case is Monday or Tuesday, true, is Monday, false, Sunday. We have statements. They're similar to switches in other programming languages. They're an alternative to using many else if statements. We execute some code if a value matches a case. Everybody, word module found within the standard Python library. You can use the help function, pass in the word modules, and then we would need to print this. Here are many of
the different modules available to you. A few you may recognize would be math, string, time. One of my favorite names of a module is the pickle module. Unfortunately, it doesn't have anything to do with pickles. It's used for serialization. To list all of the different variables and functions found within a module, you can place that name of the module within the help function. For example, with the math module, here are a few different variables we would have access to, and a few different functions. To include a module, we would type import the name of the module, for example, math. I now have access to everything found within the math module, including those variables and functions. To access those variables and functions, I would normally type the name of the module dot the name of the variable or function, such as pi. Then let's print this. Pi from the math module is 3.14 and some change. Another way to import is to type import the name of the module as. You can give your module a nickname, longer refer to this module whatever you think of, such as M short for math. We would no longer refer to this module as math. We would refer to it as our alias, some of the type to use, for instance, from useful. What if I want a equal going to print E from the math module, 871. Then let's do this with B, C, and D. E will be 5. E. We have imported E from them. We have created another version of E. We will end up using the second version rather than the version that we have imported from the math module. All my results are now different, and it's possible you may not realize it. I like to be more explicit. I'm going to import math. If I'm using a variable or function from a module, I much prefer to prefix that variable name or function with the power of B of our variable E. And these results are to be expected. Now to create a module, what we're going to think of a module name. Maybe tabs. Then click Python file. Of a module name. Maybe folder, go to new, Python file. Think of a module name. Maybe example. Then click Python file. We now have two tabs, main and example. Declare whatever you would like within this module. Let's create our own variable pi. Pi equals 3.14159. Then a few functions. Let's create a function to square an argument that's passed in. Define square. We will accept an argument which we will name x. Then return x to the power of 2. Let's define a cube function. We will accept a radius. Then return 2 times pi times radius. Then an area function to calculate the area of a circle. We will accept a radius as an argument, then return pi times radius to the power of our main pi. Result equals example utilize to the power of 2. All right, here is our example module. Within our main a pi 1415 example. Let's use the that would. It can be useful at times to separate your program into individual files. All right, everybody, in conclusion, a module is just a file. A variable is both visible and accessible. Resolution. A module is just a file containing code. File your own module. It can be useful at times to separate your program variable result and set it to our example module, which we named example. I'm going to declare a variable result and set it to the name of my module dot pi. Then I will print the result, which is 3.14159. Use built-in mod to include in your, then pass in the word modules. Hey friend, variables, that's how to get started with modules in Python. Hey friends, it's me again. Today I'm going to explain both variable scope and scope resolution. Variable scope is where a variable is both visible and accessible. With scope resolution, when we're using a variable, there is a certain order known as the LEGB rule in which we locate that variable. Local, enclosed, global, built-in. We'll get to this momentarily. Let's begin with variable scope. I have two functions, function 1, function 2. Within function 1, a equals 1, then we print a. Within function 2, b equals 2, then we print b. If I were to invoke these functions, let's invoke function 1, then function 2. We would print 1, then 2. Variables declared within a function have a local scope. Variable a is local to function 1, variable b is local to function 2. Within function 1, if I were to print b, and function 2, if I were to print a, we would run into a name error. Name b is not defined. And the same thing would apply with a. Functions can't see inside of other functions. Imagine that we're function 1. This is our house. We can see everything that's going on inside of our house. But function 2 is our neighbor's house. We can't see what's going on inside of our neighbor's house. We have no idea what b is. With function 2 has no idea what a is. That's where variable scope comes in. It's where a variable is visible and accessible. Functions can't see inside of other functions, but they can see inside of their own function. That's why we sometimes pass arguments to functions so that our functions are aware of them. Using this concept, we could create different versions of the same variable and accessible. Functions can't see inside of other functions, but they can see inside of their own function. That's why we sometimes pass arguments to functions so that our functions are aware of them. Using this concept, we could create different versions of the same variable. Let's rename a to be x and b to be x as well. Then I will print x. We have two different versions of x, a local version of x found within function 1 and a local version of x found within function 2. Whenever we utilize a variable, we will first look to see if there's any local instance of that variable. If there isn't, we would move to the enclosed scope. With an enclosed scope, one example is when you have a function declared within another function. I'm going to place function 2 within function 1. This is allowed in Python. This is a more advanced concept. We'll cover this more in the future. So I'm going to eliminate this print statement. Let's get rid of function 2. At the end of function 1, we will invoke function 2. Like I said, it's pretty complex. We won't be using this until much later. Within function 2, if I was to print x, we would use the local version, where x equals 2. If I was to eliminate this variable declaration, we would use the enclosed version instead, where x equals 1. There's an order of operations. Use any local variables first, then enclosed variables. We're printing x within function 2. Since x wasn't found within the local scope, we would use x within the enclosed scope. But like I said, that's a more advanced topic. You should at least be aware of it. Let's move on to the global scope enclosed variables. We're printing x within function 2. Since x wasn't found within the local scope, we would use x within the enclosed scope. But like I said, that's a more advanced topic. You should at least be aware of it. Let's move on to the global scope. Global meaning outside of any functions. I will eliminate these variable declarations. Within function 1, we're printing x, and within function 2, we're also printing x. I will declare a global version of x, where x equals 3. X is outside of any functions. When I run this program, we're printing 3 twice. Once for function 1, and once for function 2. There's no longer a local version of x for both of these functions. If there were, we would end up using these local versions instead. Function 1 prints 1, function 2 prints 2. If there's no local version, as well as no enclosed version, we would move on to the global version, where x equals 3. Last in our order is built in. I think what we'll do, though, is from math, import e. E is an exponential constant. I'm going to print what e is. E is 2.71. E is built in. I will create a function to print e. Define function 1. All I'm doing is... What we're doing, technically, is creating 2 different versions of e. Variables can e and a global, because using the LEG version... Alright, everybody, so in conclusion, variable resolution order, LEGB. If we're using a variable, we will first look in the local scope for that variable. If we don't find that variable in the local scope, we will move over to an enclosed scope, then global, then built-in. We will have more practice with this in the future. And well, everybody, that is both variable scope and scope resolution in Python.
Hey everybody, so today I gotta talk about this if statement. If dunder name is equal to a string of dunder main. When you see this if statement, it's usually followed by a call to a function named main, or something similar. Name is... Hey everybody, so today I gotta talk about this if statement. If dunder name is equal to a string of dunder main. When you see this if statement, it's usually followed by a call to a function named main, or something similar. A majority of the driving code behind a program is usually found within some sort of main method. When you see this if statement, basically speaking, it means that this script can be imported, or it can run standalone. Functions and classes in this module can be reused in other programs without the main block of code running. Sometimes you would like the functionality of a program without them is used if
Resolution in Python.
Hey everybody, so today I gotta talk about this if statement. If dunder name is equal to a string of dunder main. When you see this if statement, it's usually followed by a call to a function named main, or something similar. A majority of the driving code behind a program is usually found within some sort of main method. When you see this if statement, basically speaking, it means that this script can be imported, or it can run standalone. Functions and classes in this module can be reused in other programs without the main block of code running. Sometimes you would like the functionality of a program without executing the main body of code. A good example could be a library. In a Python library, we would like to import some of the useful functions, such as the math module. But if we were to run that library directly, instead of importing it, we could instead display a help page. But if we're importing that library, we don't necessarily want to display that help page, only if we're running it directly. In many Python scripts, you'll see the statement of if dunder name is running it directly. A good example could be a library.
In a Python library, we would like to import some of the useful functions, such as the math module. But if we were to run that library directly, instead of importing it, we could instead display a help page. But if we're importing that library, we don't necessarily want to display that help page, only if we're running it directly. In many Python scripts, you'll see the statement of if dunder name is equal to main. If we're not running this program directly, don't do it. In this example, we're going to delete our main Python script. Running this program directly, the statement of if dunder name is equal to main. If we're not running this program directly, don't do it. In this example, we're going to delete our main Python script. Be sure to recreate it at the end of this topic in case I forget to mention that. we will create two new scripts. Go to File, New, Python file, script 1. File, New, Python file, script 2. We have to add new run configurations for script 1 and script 2. So if you go to the top, go to Run, Edit Configurations, we will add a new run configuration. Select Python, select a new script path to script 1. OK, apply. Again, we have to do this with script 2 of script 2. Drop-down menu, we can select which run configuration we would like. Would we like to run our main Python file, but we have deleted it? Do we want the dir functions? If you're not familiar with object-oriented programming, for now, think of an attribute as a variable. Dunder name is programming, has all of these built-in attributes. Dir meaning directory, Python has all of these built-in attributes. If you're not familiar with object-oriented programming, for now, think of an attribute as a variable. Dunder name is a special type of variable. Dunder meaning double underscore. If I was to print what's contained within dunder name, we would receive a string of dunder main. That's why in a script you may see the statement, if dunder name is equal to a string of dunder main. If so, then you usually call a function named main to start your program. I'm going to undo that. So let's import script 2. From script 2, import everything. Asterisk means everything. Within script 2, I will print dunder name, and we'll see what's within it. Again, I'm running script 1. Within script 2, dunder name is equal to a string of script 2, the name of the Python script. However, within script 1, dunder name is equal to a string of dunder main. This means I am running script 1 directly. Let's delete this import. Then go to script 2, import script 1. From script 1, import asterisk meaning all. We're now going to change our run configuration from script 1 to script 2. We are running script 2 directly. Now, dunder name within script 1, we are running script 2 directly. Now, dunder name within script 1 is the name of the Python script, script 1. Dunder name. Let's delete this import dunder main and import. I'm going to undo that. So let's import script 2. From script 2, import everything. Asterisk means everything. Within script 2, I will print dunder name, and we'll see what's within it. Again, I'm running script 1. Within script 2, dunder name is equal to a string of script 2, the name of the Python script. However, within script 1, dunder name is equal to a string of dunder main. This means I am running script 1 directly. 1 all. We're now 2 directly. Now, dunder name within script 1 is the name of the Python script, script 1. Dunder name within script 2 is now dunder main. So by adding this if statement of dunder name is equal to dunder main equals dunder main, but we need to define this function. Majority of our Python code. Our main function will contain the majority of our Python code. Anything that's not already within a function. This script 1. Favorite food. I'll use an F string. Your food. Favorite food as a string. I'll type in pizza. Then let's print the word goodbye. We're going to run script 1. Run it. Here's the result. From the top down, all of our code is within functions. We skip over it because we're not calling it quite yet. The first thing we do in this program is check this if statement. If dunder name is equal to dunder main. Are we running this program directly? Which we are. We're running script 1. If so, call the main method to start the program. We print, this is script 1, your favorite food is pizza, goodbye. Now I'm going to go to script 2. Delete our print statement. Change the run configuration to script 2 and run it. Nothing should happen. That's good. Now, if we were missing this if statement of if nothing should happen, change the run configuration to script 2 and run it. Nothing should happen. That's good. Now, if we were missing this if statement of if dunder name is equal to main, then we delete our main function. Here's what would happen. We're importing script 1, but we're running script 2. This is script 1. Your favorite food is pizza. Goodbye. I don't want this code to execute. We're not running it directly. That's why we're running script 2. This is script 1. Your favorite food is pizza. Goodbye. I don't want this code to execute. We're not running it directly. That's why we have that if statement. If dunder name is equal to main. I only want to run this code if we're running it directly. So what we'll do within script 2 now is define a function of drink. Favorite. Let's print the message. We will call from script 1 the favorite food function. Pass in your favorite food. This time I'll say favorite drink. Print. This is script 2. Your favorite food is sushi. Your favorite drink is coffee. Goodbye. We're running script 2, but we're importing the functionality of the favorite food function from script 1. Sometimes from another Python script, you want to borrow something, but you don't want to run the main body of code directly. I just want to borrow this function from script 1, and that's it. Script 2 can be run as a standalone program, but I can't import it without this body of code running. I can add that if statement. If dunder name. Running this program directly, execute this code. So let's call a function of main. Define main. If I run script 2, we have the same message. So by adding this if statement of if name is equal to main, this script can be run as a standalone program, or it can be imported. A more practical example of this could be a Python library. You can import the library for functionality, but if you run the library directly, you could instead display a help page. It is good practice to include if dunder name equals dunder main. It makes your code more modular, helps with readability, leaves no global variables, and avoid equals dunder main. Create a very simple banking program using Python. Buddy, so in this video, we're going to create a very simple banking program using Python. This is meant to be more of an exercise to get us used to working with functions. When creating a project, I like to divide that project into smaller sections, then handle them one at a time. So we'll do that by declaring all the functions we'll need first. With the banking program, we'll need to show a user their balance. We'll define a function to show balance. For the time being, I'll write pass just as a placeholder. We'll need to make a deposit, define deposit with main function to contain everything. We'll need a balance boolean that is. You can check to see if we will with our choice deposit. I'm just going to type the word poo. That is not your choice. Exit. I like to divide that project into smaller sections, then handle them one at a time. So we'll do that by declaring all the functions we'll need first. With the banking program, we'll need to show a user their balance. We'll define a function to show balance. For the time being, I'll write pass just as a placeholder. We'll need to make a deposit, define deposit, make a withdrawal, define withdraw. Near the end of this project, we will be creating a main function and placing the main body of our code within it. We'll handle that near the end, just to contain everything. We have our three functions. With our banking program, we'll need to show a balance, make a deposit, or make a withdrawal. What are some variables we'll need? Well, we'll need a balance, which I will set to be 0 initially. I will also create a boolean of is running. This will be true. If at any time we set is running to be false, we'll exit the program. So with the majority of our code, we'll place it within a while loop. While is running. You can check to see if this is equal to true, but since this is a boolean, that's not necessary. We will just say while is running. If is running becomes false, we'll exit the while loop. Within our while loop, we'll print some sort of welcome message. Let's print banking program, then list some options. Let's print 1, show balance, 2, deposit, 3 will be withdraw, 4 will be exit. Afterwards, we will set a choice variable to equal some user input. Input, enter your choice 1 through 4. We're encouraging a user to type in a number 1 through 4 to select an option. Do they want to show their balance, make it a
deposit, make a withdrawal, or exit. We'll add a few if and else if statements. Let's check to see if the user's choice is equal to 1. And that is a string of 1. Our user input is a string data type, unless we were to typecast it to something else. If our choice is equal to 1, we will call the function to show balance. Else if our choice is equal to 2, we will make a deposit by calling the deposit function. Else if choice is equal to 3, we will call the withdraw function. Else if choice is equal to 4, that means we would like to exit. So we need to exit this while loop. We can do that by setting our variable is running. Is this program running? Valid print choice. Okay, let's see what balance deposit are we. And 4 to exit. Processed finished with exit code 0. So we can exit the program, we just have to select option 4. With this else statement, this will execute if we type in something besides the numbers 1 through 4, because there's no other options left. So to test that, enter your choice 1 through 4. I'm just going to type the word poo. That is not a valid choice. So we know that the else statement is working. Once we exit the while loop, let's print a message that says, "Thank you, have a nice day." If I was to type 4 to exit, we should exit the program. Thank you, have a nice day. Let's make that H capital. Now we'll work on our functions, beginning with show balance. Currently these two variables are global. We don't need to pass them as a parameter to these functions quite yet. We will be enclosing all of this code within a main function. We'll handle that later though. So with show balance, all we're going to do is print. I'll use an F string. Your balance is, add a $sign, or other unit of currency of your choosing, add a placeholder, our balance variable, and let's see what we have. I will type 1 to show balance. Your balance is $0. I'll display our balance with 2 decimal places after. I will add a format specifier after balance. Colon, point to F will add 2 decimal places. We covered format specifiers in a previous topic. So if I were to run this again, type 1, we show $0 and 0 cents. We're displaying 2 floating point decimal places. Now we need to make a deposit. That'll be the next function. We will define a local variable of amount equals accept some user input. Enter an amount to be deposited. Again, when we accept user input, it's a string. we'll typecast it to a number, a floating point number, because we have to include dollars and cents. We'll add some checks, though, after accepting some user input. If our amount is greater than 0, we don't want anybody to make a negative deposit. Let's print that's not a valid amount. Else, we are going to return our amount. So this function is going to return something. So within our else if statement, we will take our balance plus equals the deposit we're being returned with. This will add our deposit to our balance. Balance plus equals deposit. Let's try it. We'll make it a dollars. Type error. Unsupported operand for statement. Let's just return any. On. Floating point. User shouldn't be able to withdraw more money than what they have in their bank account. If the is with our if and else if statements, we do need to return something. If we take one of these routes, we will return 0. We're not making any changes. Within our else if statement, where we select choice 3, we're going to take our balance minus equals the withdraw amount. Let's test this. Banking program. Let's show our balance. Our balance is 0. We'll make a deposit of $100. Show my balance again. Your balance is $100. Let's press 3 to withdraw money. Enter amount to be withdrawn. $1 cajillion. Insufficient funds. Yeah, no kidding. Let's attempt to withdraw money again. We shouldn't be able to select a negative amount. Negative $420.69. Amount must be greater than 0. Let's enter in a valid number this time. I would like to withdraw $49.99. That has appeared to work. We'll show our balance again. Your balance is now $50.01. Then we can exit by pressing 4 to exit. Thank you and have a nice day. The last few changes I'm going to make is that I'm going to enclose all of this code, our main portion of code, within a main function, just to encapsulate all of our variables and help with readability. We will define a function of main. Take all of our code within the main body of our program and place it within the function. I'm just going to select all of it and indent it. At the end of our program, we need to call a main function to run it.
If you're familiar with the statement of if dunder name is equal to a discuss this notion. However, our variables of balance and is running, they're now enclosed within this local scope. These other functions have no idea what these variables are of balance. So we need to pass in our balance to those functions of withdraw and show balance. Same thing with withdraw. Parameter we willers. Insufficient funds, balancing I stay on. As or print the row, pay of done drives our code within our main starting $100. We'll
we'll need to display some sort of welcome message. Let's print something. We will print welcome to a lemon for some picking balance. We need digit type. Let's reassign our bet. Typecast our bet as an integer. Then we will check that they don't have $0. Import random from this list row function argument. Every time we 0 is a cherry emoji, we have to return layout. Other equal in something. Price or bet amount n. I'm going to include some punctuation would chosen at random. At the end of our program, an F string. Banners
amount, I'll bet $1. Sorry, guys. Alright everybody, so that is a slot machine. I'll show you how we can write a substitution cipher encryption program. Basically speaking, what we're going to do is that we have a message. To hide the message, we can encrypt it by replacing every instance of one character with another, chosen at random. Using the same key, we can then decrypt the message. When I was at my university, I took an Intro to Cybersecurity course. I turned this program in as a final assignment, and I did get an A on it. I don't know, maybe it'll help you. At the very least, it's a good exercise. Alright, let's get started everybody. We will begin by importing the random module, as well as the string module. Let's create a string of characters named chars. Whatever characters you would like to use for your encryption program, list them here as a string. However, this can be a lot to write. I think a better solution would be to import some constants from the string module. I'm going to include some punctuation. I will import the punctuation constant of the string module. How the heck do you spell punctuation? Okay, that's right. Plus, I will add some digits. String dot digits constant plus string dot ASCII letters. Let's take a look at our characters so far. We have one long string of characters. What if I would like to include a space, a white space? Well, there is a constant for that, but that includes things like carriage return. That's going to warp our results. Let me show you just for a demonstration. String dot white space plus all the other stuff. We have a carriage return and some other characters. I would like to avoid that, so in place of importing the white space constant from the string module, I'm going to add a space character. That's good enough. Here are all the characters I will be using this program. Feel free to add more or less. This is all one long string. I'm going to turn the string into a list, where each character is an individual element. To do that, I'm going to take our string of chars, reassign it, then typecast my string of characters as a list. Then let's print it again. Print chars. Instead of one long string, we have a list. A list of all the characters we'll need. I am then going to create a key, which we will shuffle eventually. Key. Then to create a copy of a list, you can type the original list dot copy method. Then I will print my key. I'm going to place these lists within an F string. Chars. Then I'm going to place these lists within a list need. Then to create a copy of a list, you can type the original list dot copy method. Then I will print my key. I'm going to place these lists within an F string. chars. One for the original characters, and the other for the key. Random.shuffle, pass in our list of key. Look at that, all of the characters are now shuffled in a random order. What we'll be doing when somebody types in some text to be encrypted, we will program, we will do some message. Enter a message to encrypt. Ciphertext is the name of the encrypted message. That will be an empty string. Okay, let's say a user types in a message. Enter a message to encrypt. I like pizza. It's a very important message. Every instance of a character within my plaintext, I will refer to the key and replace that letter with a different one. For example, any Z's, I have two Z's in this program, will be replaced with, let's see, capital B. Every time we run this program, though, it's going to find the index of every letter from our plaintext within our list of characters. Let's assign a variable index. Index equals, take our list of chars, use the index method. We are looking for that letter, whatever letter we're currently on. Then return an index. Then refer to our key, get whatever letter is at that same index. So we will append that to our ciphertext. It's currently an empty string. Ciphertext plus equals our key at the given index. Our ciphertext should be the encrypted message now. Let's print it out. Print, I'll use an F string. Original message. Let's print our plain text. Then our encrypted message. Print our ciphertext string. Let's take a look so far. Enter a message to encrypt. I like pizza. Then here's the new encrypted message. Every instance of a character within my plaintext was replaced with another message. Empty string, same index, with a different. This part of our program. program, we will do original message and replace that letter with a different one. For example, NEZ is iterated in, return it at that to our. Then here's the new encrypted message. Every instance of a character within my plaintext was replaced with another. So for example, NEZs were replaced with E. I have two E's within this encrypted message. If I were to run this program again, it would likely be different. Our encrypted character to our plaintext within our list chars at a given index. We will display our encrypted message followed by the original message. Let's try it one last time. Enter echoes. If I were to decrypt the encrypted message, it should give me my original. Hit enter, and here is my message decrypted. I like tacos. All right, everybody, so that is a substitute decrypt chars to our plain. It's probably best for us not to display the characters and the key, so let's hide those. We will be reusing this key for decryption. Now to decrypt the message, let's copy this section of code, paste it, we are now decrypting. We will ask for some ciphertext, then reset our plaintext. For every letter in our ciphertext, refer to to our key. And here is my message decrypted. I like tacos. All right, everybody, so that is a substitution cipher encryption program for beginners. When I was at university, I did turn this program in for a final assignment for a cybersecurity class, and I did get an A on it, so maybe it'll help you.
So let's create a few words. I'll add some fruit. Apple, orange, banana, coconut, and one more. Will be a... We will... We lose the entire... We no longer need them. Lose the game. 6, their right leg. Once we see code, we know the code of our program. I'll add the separate apple. Here we go. We have characters. I need the number R is working. Apple, apple, pineapple, apple. I guess it really likes apple for some reason. There we go. We have orange. We are choosing a word at random. Thing is working fine. It's going to list where we have that is protect. We next set. We don't need to comparison. For each character, now when we do characters, we need to switch it. Our is that will iterate if our we will use I'll add our answer variable print of. So the length of our hangman art will key coconut. We have 6 incorrect guesses. We display the entire hangman. The correct answer was coconut. You lose. If you would like to import a larger variety of words, we could create a set. Usually people know what your Python file. Let's take our set of words, cut it. I'll aim online from my main Python file all the possible words for my game. So, list of words. Out. Nope. Boar. Alright, the word was boar. You win. Hey everybody, so we have finally made it to Python object-oriented programming. Hey everybody, so we have finally made it to Python object-oriented programming.